Over its 9-year mission, NASA's Kepler telescope turned its gaze to over 500,000 stars, revealing that 20–50% of all visible stars could harbor potentially habitable, Earth-sized rocky planets. In our relentless search for extraterrestrial neighbors, we've already uncovered over 5,500 exoplanets, dozens of which might have conditions suitable for life. And many other planets are so bizarre they capture your imagination. And NASA continues to find new alien worlds almost every day. But recently, scientists have discovered a very strange planet that might not just be habitable, but could have a form of life that turns our entire worldview about life upside down. Now get ready to discover how astronomers found a planet that shouldn't exist, see another celestial body that is a cosmic mirror, and watch how another planetary system performs an interesting cosmic mathematical dance, and much more. Many studies have been done and concluded that life has more chances to emerge around red dwarfs than stars like our Sun. And there are more red dwarfs than any other type of star in the universe. Red dwarfs are also the smallest type of hydrogen-burning star. In 2023, astronomers stumbled across an intriguing exoplanet around the red dwarf star TOI 715, located in the constellation of Volans, 136 light-years away from us. Astronomically speaking, this is in our celestial neighborhood, like a house just down the block from where we live. The red dwarf star TOI 715 is orbited by the super-Earth planet TOI 715b. What defines an exoplanet as a super-Earth is its mass, which has to surpass that of Earth. TOI 715b is 3 times as massive as our planet, and it is about 1.5 times the Earth's radius. To even consider a space object habitable, among all other things, it has to be either a water world or a rocky planet. By analyzing the exoplanet's parameters, scientists can make predictions about its composition, determining whether it falls into the category of a gaseous, rocky, or watery world. Usually, planets that are between 2 and 10 Earth masses and a diameter between that of our planet and Neptune turn out to be rocky. But it's not only the exoplanet's mass and size that make it special. Located at just the right distance from its star, TOI 715b receives enough heat to possibly have liquid water on its surface. And where there's water, there could be life. Red dwarfs like TOI 715 often have several worlds tightly packed within their habitable zone. Astronomers theorize that there could be one more planet in the system, TOI 715c, just about 7% larger than Earth. If the theory holds true, it will be the smallest exoplanet ever discovered in the habitable zone by NASA's Transiting Exoplanet Survey satellite. In our cosmic quest to find habitable worlds, planets like TOI 715b seem to be our best contenders. Despite our limited knowledge about this newfound exoplanet and its potential neighbors, imagine the excitement if future observations uncover an atmosphere and even bodies of liquid on its surface, like those we have once spotted on Saturn's largest moon, Titan. The possibilities are thrilling. Perhaps one day our descendants will be navigating vast, uncharted landscapes, seeing the unknown creatures roaming around this alien terrain. But let's move on to other recently discovered exoplanets. Unfortunately, not many exoplanets we find are habitable even in theory. Some have conditions so terrifying we wonder how they came to exist. On average, the chances of finding an inhospitable exoplanet are much higher, and these planets raise a lot of questions within the scientific community. One such celestial marvel sits at a distance of around 264 light-years from Earth, LTT 9779b. So, what's so special about it? What you see here is one of the planets called ultra-hot Neptunes, with a surface temperature of 3,650 Celsius, 2,000 Rayleigh-C. But LTT 9779b isn't just that. It's the most reflective exoplanet we've ever detected. The blazing hot world is roughly 5 times wider than Earth, and reflects about 80% of the light coming from its star. To compare, Earth only reflects about 30% of sunlight. What makes it a gigantic cosmic mirror is an abundance of reflective clouds of metal, with titanium droplets raining down on its surface. The problem is, as scientists say, it's a planet that shouldn't exist. The side of the exoplanet that faces its host star is extremely hot, so hot that neither clouds of water nor even clouds of glass or metal should form in its atmosphere. According to our current understanding, a star located this close to an exoplanet should strip away its atmosphere completely. So, what happened there? Researchers compared the phenomenon to condensation in a steamy bathroom. If you let the cool air in, water vapor will condense, and if you let the hot water run, eventually the air will be so full of vapor it wouldn't be able to hold anymore. Something similar could have happened on this ultra-hot Neptune when the planet's atmosphere was filled with silicate and metal vapor because of the scorching temperatures on its day side. But the exoplanet's uniqueness doesn't end here. Throughout decades of observations, we've detected a multitude of worlds orbiting their host stars in under one Earth day at a very close proximity. But all of them were either hot Jupiters 10 times wider than Earth or rocky planets over 2 times smaller in size than Earth. There was a population of missing planets whose sizes would fit in between these categories. Scientists called this gap the Neptunian Desert. Until finally, we've stumbled across LTT 9779b, which, by its parameters, fits right in the middle. In a way, the exoplanet's reflectivity is its survival mechanism. If it absorbed much more heat from its star, over time, the planet would slowly evaporate. LTT 9779b is a perfect target for follow-up observations by the Hubble and James Webb Space Telescopes. Perhaps our technologies will reveal even more mysteries behind this already enigmatic celestial object in years to come. The planet we're about to discuss was discovered over a decade ago, but scientists have recently learned something about it that deserves a spot on our list. WASP-76b, located 637 light-years away, is nearly half as hot, for 350 gambis or 2,400 agaras, as our Sun, almost twice as wide as Jupiter, but just about 90% of its mass. The scorching temperatures are explained by the planet's close orbit around its star, just about 3% of the Earth-Sun distance. Even Mercury, the closest planet to the Sun, is located 10 times further away. The place would be a perfect crematorium, since human bones, which primarily consist of calcium, vaporize at approximately 1,500 degrees Celsius. On top of that, one of the planet's sides is tidally locked to the yellow-white WASP-76 star, which results in different temperatures across the exoplanet and brings about a weird phenomenon. Throughout the years since the planet's discovery, researchers have studied the composition of the exoplanet, discovering 11 chemical elements in its atmosphere, some of which turned out to be rock-forming, or at least that's what happens to them on terrestrial worlds like Earth. But because of the blisteringly hot temperatures on WASP-76b, elements like magnesium and iron turn into gases that reside in the planet's upper atmosphere, and once strong winds carry these iron and magnesium vapors to the night side of the planet, they cool and rain down as molten droplets of metal. Some planets out there in the universe are extremely different from what we have in the solar system, and WASP-76b isn't even the most drastic example. Recently, astronomers uncovered an extraordinary star system just 100 light-years away. Dubbed HD 1167, it contains 6 subneptunes, planets 2 to 3 times Earth's size. All the exoplanets in the system are unusually close to their host star, with orbits that would fit between Mercury and the Sun. Unlike our solar system, which has been continuously changing, HD 1167 appears to have maintained its structure, for over 1 billion years. The 6 planets are synchronized in one perfect celestial dance that scientists call resonance. The way these sub-Neptunes orbit resembles fractions in a mathematical equation. By the time the first planet completes 3 orbits, the second world revolves around its star twice. Each subsequent planet follows the rhythm, with the 4th sub-Neptune, for example, orbiting the star 4 times for every 3 orbits of the 5th planet, and so on. This discovery is exceptionally rare. Usually, young planets maintain these rhythms for a brief period until something goes wrong, like a passing star or more massive planets in the same system, disrupting the balance due to their strong gravitational influence. Over 1,000 light years away, in the constellation Pictor, sits a binary star system, Bebop 1. That's where scientists have recently identified a new member, the exoplanet Bebop 1c. And it's not a typical planet as we know them. It belongs to the category called circumbinary planets, or those that orbit 2 stars instead of 1. They are quite scarce in our cosmic catalog, with only about 15 known so far. But there's more. It's the second circumbinary system that hosts more than 1 planet we've ever been able to detect. Interestingly, about 85% of stars in the universe aren't like the Sun. They usually have 1 or more stellar companions. In the Milky Way alone, there are star systems with clusters of 7 stars. Based on our current understanding, single stars only make up about 15% of all stars in the cosmos. The newly discovered world is approximately 65 times more massive than Earth, which makes it a gas giant like Jupiter or Saturn. Just imagine how breathtaking it would be to stand on its surface, surrounded by a double sunrise. Unlike ordinary disks of matter surrounding a single star, in circumbinary systems, the planet-forming disks rotate around both stars, creating disturbances that make it challenging for planets to form. As a result, it's only in the calm corners, away from the stellar chaos, that planets have a chance to be born. Discoveries like this remind us of the endless celestial gems we're still about to uncover, even those that were once purely science fiction.